In today's video, we're going to look at the law of cosines and how it can be used to solve for unknown parts of oblique triangles. First, let's start the Edmodo quiz with a little bit of review. In which two situations can you not use the law of sines? In order for Edmodo to grade you correctly, make sure you give your answer in letters, as in angle side angle would be ASA, and give your answers in alphabetical order. If you're stumped, draw some triangles. Can look at it and say, well, if I knew this, and I knew this, and I knew this, would I be able to use the law of sines? And you can experiment with different combinations and see which ones it wouldn't work for. Go ahead and pause now, and then restart once you've answered. Now that you've answered that introductory question, we're going to begin the proof of the law of cosines. At this point, put your pencil down, don't take any notes, just follow along. Pause when you need to, but listen carefully to follow along the proof for the law of cosines. Now to begin looking at the law of cosines. This involves a bit of a proof here, but please note the triangle ABC. C is an angle that is centered at the origin, so the ordered pair for that point is 0, 0. Angle B is on the x-axis, so its y value is 0. Its x value is the distance from the origin in the horizontal direction. In this case, we would call that side A of the triangle. So the ordered pair for angle B, that point, that vertex, is A0. Vertex A, on the other hand, appears to be out here in space. So I'm going to generally call that point XY. It could be any XY. The x is the horizontal distance from the origin to underneath vertex A. The y value is the vertical distance from the x-axis up to vertex A. So you'll notice that you have a little right triangle inside of the larger triangle that goes up towards vertex A. Now, you'll notice that they give a different ordered pair in the diagram. Let me show you how that comes about. Consider angle C. The cosine of C, using right triangle trig, is the adjacent side of that right triangle, x, over b, the hypotenuse. So I can solve that for x. B cosine of C is equal to x. And so you notice the x-coordinate in the on the diagram is b cosine of angle C. We could do the same thing for the sine of angle C. That's equal to y over b. So y is equal to b times the sine of angle C, and that value is plugged into that ordered pair as well. Now that we've labeled all of these parts, the law of cosines is derived from the distance formula. Now, in order to remember the distance formula, let's focus in on this right triangle on the right side of our large triangle. It's got side C as the hypotenuse. Essentially, the distance formula is the Pythagorean theorem in a coordinate plane. And so we can use the coordinates to come up with the distances that we have going vertically and horizontally. So remember, the Pythagorean theorem, or the distance formula, will say the hypotenuse squared is equal to the sum of the squares of the two sides. The first of those two sides is the horizontal one. That distance is equivalent to A, which is the whole length, minus x. So we have c squared is equal to a minus x squared plus the vertical side, which is this value y that we see here. So that's y squared. This is the distance formula. And this formula, along with these other values that we have mentioned earlier for x and y, will provide the basis for the law of cosines. So we're going to go to the next slide, and I'm going to include these values there. At the top, notice that I've carried over all of the formulas that we had from the previous one. And what I'm going to do is start substituting for x and y. So we get rid of those x's and y's which are fixed in the coordinate plane and start subbing in parts of the triangle that we had, the b cosine c, b sine c. So that's the first step. C squared is equal to a minus b times the cosine of c, I just substituted for x, plus y squared, which is b sine of c, and that is also squared. Now we need to FOIL and distribute these quadratics. C squared is equal to a squared minus 2 times ab cosine c, that happens twice, that's why it's 2 times, plus b squared cosine squared c. That's how that first binomial right here FOILs. Then in the second part, since it's all multiplication in the parentheses, we can simply distribute the square. Now notice that tail end of our current equation here. I'll put it in brackets. B squared cosine squared c plus b squared sine squared c. The cosine squared plus sine squared jumps out a little bit at us. If not, let's look at it when I factor out the b squared. Cosine squared c plus sine squared c, which by now we're all familiar with. That's an identity which equals 1. So when we take that out of the equation, since it is just multiplying by 1, we're left with a squared plus b squared, I just reordered some things, minus 2ab cosine of c. This is one version of the law of cosines. On the next slide, we'll look at all of them. Now you can pick up that pencil and start writing some things down for your permanent notes. The law of cosines for triangle ABC with sides A, B, and C. You'll notice there are 3 versions of it, but they're all the same. You don't need to memorize all 3 versions of this. Essentially, you have one of the sides and its opposite angle. So a squared is on one side of the equation. The opposite angle is the only angle in the formula. And then the other pieces are the other 2 sides. Take a minute and pause if you need to continue writing these down. Like we did with the law of sines, we want to generalize and figure out when we can use the law of cosines. So let's look at one version of the law of cosines here. This is the one using angle A and side A on the opposite side. So look at some possibilities. Knowing angle A and the 2 adjacent sides. So knowing side angle side gives you all of the information on the right-hand side of the law of cosines. Side B, side C, side B, side C again, and angle A. Then you can just do the calculations on the right side of the equation to find the opposite side, A. It can also be used in a side-side-side situation. So if you know side A, side B, and side C, you could plug those in to all of the sides and use the formula to find the angle A. Of course, if you reordered it, you could put b squared over here and you could find angle B if you wanted to. Lastly, this can be used in a situation where you know angle side side. So if we knew angle A, side B, and side A, the only variable left in the law of cosines would be C, which appears twice. Notice that it would be a quadratic equation for C. Again, we'll have a totally separate video that will analyze the angle side side situation. For today's, we're going to focus on just the side angle side and side 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 situations. You can't use the law of cosines in situations when you know 2 angles and a side. Notice that there's only one angle in the law of cosines. So if you know 2 angles and a side, you want to use the law of sines instead. Take a moment now and answer number 2 in your Edmodo quiz. It's a fill-in-the-blank question. The law of cosines is derived from blank formula. Let's look at our first example using the law of cosines. Notice in this case we know side, side, side. Obviously that means we have to solve for an angle. And the nice part about side, side, side is that you can pick any angle that you want. In a word problem you might be given a particular one, so you can go directly to that one. In this case, eventually we would find all three angles, so it doesn't matter where you begin. For the sake of starting somewhere, let's go for angle B. So we're going to use the version of the law of cosines that has angle B inside the cosine and then side B on the opposite side of the equation. So notice that means we have sides A and C in the more complicated part. Now it's a matter of plugging in all the values that we know. Side B is 8, side A is 5, side C is 7, and of course side A and side C are plugged in twice, and we still have that variable B for the angle. Now let's take away these squares really quickly, and the next step will be to isolate the cosine so that we can then take the inverse cosine. So first we need to subtract these values to the left-hand side. 64 minus 25 minus 49 is negative 10. We've already done the multiplication to find that negative 70 cosine of B is left. Divide both sides by negative 70, we get positive 1/7 is equal to the cosine of B. Therefore, angle B is equal to the inverse cosine of 1/7, which is roughly, using your calculator, 81.79 degrees. Now you would have some options to move forward and find the other angles. You could use the law of sines. However, I believe the most accurate and easiest method of finding the next angle, either A or C, is to use the law of cosines a second time. Once you have two of the angles, then you can go ahead and subtract from 180 degrees to find the third angle. So let's look at an example for you to try. Numbers 3 and 4 in the Edmodo quiz ask you to find side C and angle B using the law of cosines twice. I'm giving you side, angle, side in this situation, which is the easier of the three situations in which you can use the law of cosines. Since you have everything on the right-hand side of the equation of the law of cosines, you can easily find side C using the law of cosines the first time. Then you're going to use it a second time, just like we did in the previous example, to find angle B. Like we did with the law of sines, we left one situation unexplored in this video, the angle side-side situation and how the law of cosines can be used to solve the angle side-side situation. Based on the formula for the law of cosines, how can it take into account situations in which there are 0, 1, or 2 triangles? To explore this opportunity, look at an angle side-side situation, plug in the values into the law of cosine, and see what's left in the equation and how that could be used and helpful in an angle side-side situation, the ambiguous case.